Alrighty, class.
Yes.
Thank you for showing up today so you can do these notes. Wait, oh yeah, I gave it to you yesterday. Alright, good. Okay, so we're going to go over a little bit of notes and then I'm going to give you time to make sure you're able to work on the assignments that you need to. So, hopefully when I give you time in class to work on stuff, you don't just sit out there, play on your phone, look at your Snapchat, look at your TikTok videos, or look at cat videos, because you're supposed to be doing your homework. So, let's go ahead and go through this so I can give you time to apparently look at cat videos instead of doing homework. Alright, so trigonometric functions, non-acute angles. Now, reference angles. This is kind of annoying. I hate the way that they actually do this, but a reference angle is important. Now, all the time that the reference angle that you're talking about here, so if you notice in quadrant 1, it doesn't have anything there, but this one right here is in quadrant 2. My reference angle is always going to be my angle, the shortest distance to the x-axis. That's always going to be the reference angle, the shortest distance to the x-axis. So it's always going to be less than 90 degrees. It's the shortest distance to the x-axis, right? Okay, so that's your reference angle. So now all the way, if it goes all the way down to right here, this is 180, isn't it? Say yes. Okay, so all the way over, so if it goes all the way over, that's 180 degrees. That's half a circle. 180 degrees. Now, if I want to figure out my reference angle there, I would take 180 and do what? I want to figure out my reference angle there. Subtract, right? Let's say, for instance, this is a 120 degrees, right? If theta is 120 degrees, my reference angle, which I'm referring to in red right here, I would subtract to get this angle right here in red. So I would do, to get my reference angle that looks like this, it would be 180 minus whatever my theta is. Does that make sense? So yes? No? Maybe? Okay. So to get it, and that's only in quadrant 2. What about quadrant 3? Quadrant 3, let's look at it right here. Quadrant 3, look where quadrant 3 is at over here. So if I said that this has to be the shortest distance to the x-axis, it's going to be this right here. And I know right here the x-axis is going to be how many degrees? Say 180. Okay. So how do you think I would actually get that one? Subtract what? Theta from 180? Isn't that what I did for quadrant 2 though? Think about it. You can figure it out. Come on. Subtract what? Not 360, because 360 is all the way over here. Okay? I only want to know what this little piece is right here in red. Huh? It could be, but I'm trying to set up a formula for this. So if you look at my quadrant 2, I said it's 180 minus theta to get my reference angle. To get my reference angle, I would do what? Yeah. This one right here, this is theta, right? And this is theta prime. Oh, no, that's the origin. So let's say, for instance, this theta, the one in blue, let's call that 200.
Yeah.
What would I do to get my reference angle there? Huh? Minus 180. I'm going to subtract 180 because I want to get whatever, just this little piece left, right? So I need to subtract the entire top part of this, right? So I would take my theta and subtract 180 because I want to get rid of all that other stuff. So only thing is left is going to be this little piece right here, right? Now that you're using your noodle, let's look at it in quadrant 4. Again, shortest distance to the x-axis. So right here, where do you think the x-axis is right here? What? 360, very good. So that's 360 right there, right? Okay. So think about it. What would I do to just get this little piece right here? Subtract. What am I subtracting? Okay, so I'll give you a value for this. Maybe that helps. So let's say theta over here is 300. 360 minus theta. So my theta prime, that's what that means. It is 360 minus theta. So that would tell me that whatever this angle is over here, in this case, this reference angle is how much? It'd be just 60, right? So if I throw in some numbers, it makes a little bit more sense. So what we did right here is we made formulas for all these. So we made formulas to get reference angles on all these. Okay, reference angle is always found with the reference to the x-axis. The shortest distance to the x-axis. That's what I'm looking for. Find the reference angle of 218 degrees. Okay. Now, what quadrant is that in? It's in quadrant 3, right? And what did I say about the references in quadrant 3? Theta prime is equal to, I had you write it down. There you go. Theta minus 180. So in this case, what is my theta on this problem? 218. So to find my reference angle, which is my theta prime, is equal to 218 degrees minus 180. So here my theta prime is going to be there we go. Is that pretty easy now? Now does it make sense? Now that we throw some numbers in there, now you can actually see it and be like, oh, hey, makes more sense. Uh-oh.
Oh, no, that's crazy.
Now, what do I have to find for this thing? Is this keeps going around the circle, right? But I don't want it to go around the circle a bunch of times. So what do I have to do? I have to find something special. Anyone remember that vocabulary word? The what? No.
What was the sentence for what? Describe it to me.
I'm going to find that, well, my angle has to be between 0 and 360.
The least positive.
Yes, the least positive angle. But what was the vocabulary word on the least positive angle? Coterminal. Coterminal. We're going to find coterminal. So my angle has to be between 0 and 360. So let's go ahead and start. What do you think I should do to this 1387? Minus how much? 360, right?
Yes.
Okay.
That's 1,000.
You have to put it in the calculator, right? And then you're going to have to keep doing it a bunch of times until my answer is between what? 0 0 and 360. One, 0. 6 what? Alright, still not enough. What is it? Now, is that between 0 and 360?
Yes.
Now, what quadrant is that in?
That's in quadrant. Oh, isn't it like 4? Yeah, that one. Because that one is so quadrant 1 is 0, 90,
Yeah, it is. It is quadrant 4. Did we write something down for quadrant 4?
Yeah, actually, I think.
How did I get quadrant 4? So I said theta prime.
Theta prime equals 469 theta.
There we go. So, do we know what my theta is now? It's 307. So let's go ahead and do that. Three. It's pretty easy now. So having a reference and actually seeing it with numbers over and over again, hopefully that makes it a whole lot easier. Alright, so here's the same thing, but I wanted you guys to try and make it first. I wanted you guys to actually think about the process to actually get these. Because if I give you formulas, it doesn't mean anything. But if I make you think it out and come up with it yourself, then now it makes something. So if it's in quadrant 1, guess what? It is what it is.
Oh.
In quadrant 1, it is what it is. So, yeah, you don't have to do anything because that's the shortest distance anyway. So your reference angle, if it's in quadrant 1, your answer is whatever it is. Alright, so example 2. Is that the one? Yeah. Find the 6 trigonometric functions for 210. So part of this is already done for you because if you look at the diagram, because 210 is going to be 180 and 30, right? That's going to give you this, right?
Yes.
So I did my theta prime equals 210 minus 180, which gives me 30. All right, so now, if you notice, everything's in X, Y's, and R's now, but didn't we learn something about this on our last unit? Say yes.
Yes.
It's a 30, 60, 90, isn't it? 30, 60, 90. So, on the 30, 60, 90, what's the Y value going to be right here?
You got me. What, you say it one more time?
What's the Y value going to be? You still got those notes in front of you, right?
Maybe. 2.
That one's not 2.
You said 30, 60, 90?
So
it's gonna be 30, 60, 90. It's gonna be.
So across from the 30, you're gonna put what? 2. Not 2.
It's not. It's like. Whatever. Yeah. It's like n stuff. It's like.
Yes, it is.
So it's 30, 60, 90. So it's n and then 2n and then n.
Okay.
Gradually.
So on this problem right here, so given this, I'm gonna help you guys cheat on this. All right. You ready?
Yeah, I'm just.
Okay, so since I'm going to help you cheat on this, you guys could actually just do it like this. So we could say that this is going to be 1, and this one over here, R, would be? Nope.
Oh.
Because the hypotenuse is double, right?
Oh, the other one.
The hypotenuse is double, and then the x value here is going to be?
Now one is.
Just write 3.
Yeah, right, yeah.
1 write 3. Now, the reason why we do it like this, if this was a normal unit circle, my radius would be 1. And so that the blue line from my origin down to point E would be 1. But these are all ratios, and they're all going to work out the same. So if you plug in these numbers right here, it's going to make your life a whole lot easier. So we know my x value is going to be, x is rad 3, y is 1, and r is 2. So now we have to do the 6 trigonometric functions. So sine.
Sine is
Y over r.
Yeah.
Okay, so I keep going over these over and over and over. X, y, and r. You gotta memorize these.
Y over R, so it's
1 over. Very good. Cosine. X over r. So that's going to be. Very good. Tangent is. So it's going to be 1 over rad 3, isn't it?
Yes, we gotta rationalize it.
Very good. Got to rationalize it.
This would be rad 3 over 3.
Yep. Cotangent is what? Cotangent x over y. So my x value is,
X is rad 3.
y is, all right. Secant. Secant is, okay, so it's going to be r over x. It's r over x, isn't it? Secant is r over x. So my r value, I'm plugging it in first. So that's why it's 2 over rad 3. And yes, you do rationalize, so you come up with, and cosecant. What is cosecant? R over y, very good. R over y, so my r value is 2. My y value is, hopefully you guys find this pretty straightforward because we keep doing the same thing over and over again, x, y, and r. So I'm going to stop right there. Okay, make sure you like, share, and subscribe. You hit that notification button and support my channel, buy stuff from my merch store.